Hello, and welcome to Phil Brown's Computer Networking Lab. You're watching the instructional video called Wi-Fi Protected Setup. This video is to demonstrate the security weaknesses created by the Wi-Fi Protected Setup system. The WPS wireless standard was created to make it easier for non-technical people to set up encrypted Wi-Fi connections. It is adopted by most of the consumer router manufacturers. It works by entering an 8-digit number, usually printed on a sticker on the back of the router. If a client was to send the router the correct WPS PIN number, the router would give the client the WPA passphrase. WPS PIN numbers are 8 digits long, which means a hacker would have to try 100 million combinations in order to be sure of guessing the correct code. A major weakness of the WPS protocol is that the client using the protocol only needs to transmit the first 4 digits of the WPS code, and the router will reply by telling the client if the first 4 digits are correct. It is therefore possible to brute force the first 4 digits. Once the first 4 are found, the next 3 can be brute forced. The last digit is a checksum that is calculated from the first 7 digits and does not add to the number of combinations that the hacker must test. As a result, the complexity of the problem is reduced from 100 million down to 11,000 combinations. I would strongly suggest disabling the Wi-Fi protected setup on any networking device under your management. We are now on a Linux operating system known as Backtrack 5. What we're going to try to do is to crack the wireless protection setup of a router. In this terminal window, I'm going to create a virtual interface from this physical interface called WLAN 0. Here we can see the virtual interface called Mon 0, which is in monitor mode. Now I'm going to use the wash command to view all the wireless access points nearby that are using the Wi-Fi protected setup. Here are lists of the access points. We'll try to connect to the covert.net access point and see if we're able to get the WPA passphrase from it. I'm going to use this reaver command to try to hack the access point. The reaver command will send the first 4 digits to the wireless access point, asking them if the first 4 digits are correct. There's only a total of 10,000 possible combinations of what it can be. When it finally finds the first 4 combinations, it will start brute forcing the next 3 combinations until it gets the correct answer. The very last digit is a checksum of all the first 7 digits, so we do not need to brute force the last digit at all. I'll turn off the video recording until Reaver finishes finding the correct Wi-Fi protected setup PIN number. Here we can see that Reaver has finally found the correct PIN number for the wire protection setup. It has also given us the WPA code that was configured inside of the router. It is Philip Brown 1. Another reason why it is best not to use Wi-Fi protected setup is because even if someone was to change the passphrase on the router, if the hacker knows the Wi-Fi protected setup PIN number, he can always access the router again. It does not matter how complicated the WPA code is, just having the Wi-Fi protected setup pin number will always allow a hacker to access the router. In this video, we have looked at why it is important not to use Wi-Fi protected setup on routers. I hope this video has been informative, and I thank you for viewing.